Welcome back, everyone. So the main agenda item for today is we're gonna debug, basically. So we can go through the data sets that were posted to Slack. We can, make whatever figures you're excited about. We can look at new data sets if you found stuff. We could talk about, like, if you have a specific question that you think could be answered with a data set, how can you actually go about answering that question? You can brainstorm analysis ideas or figure ideas. It's a totally open time. So who would like to bring anything up? Yes, Anna Marie.
I guess it's more of a question rather than a proposal, but I was wondering, are we just supposed to do like descriptive statistics?
Well, it's up to you, but yeah, that seems like a good place to start. Is just, yeah, so if you want to show some set of observations is increasing, you could show a line plot or a bar plot. You could attempt to quantify it too, but that's not necessary for this class, but you're welcome to. So if you've taken one of the stats courses at Dartmouth or AP stats or the equivalent, we could introduce various statistical tests. Happy to chat about that too.
Okay, I'll take that into account. Thank you.
Sure. Yes, Frank.
So what if, as I said, if there are some data sets that are not in the CSV format?
Yeah, so what formats are the data sets in? Do you want to share them in Slack or on the Zoom chat?
I'm not sure. I saw there's Microsoft Access format and there's SAS formats. So I don't know, there's a number of different variations.
Got it. Yeah, so if it's in a standard format, like a Microsoft Access database or sorry, what was the other format you mentioned? Is it SPSS?
It says it's SAS.
SAS. Okay, yeah, that's another format. Yeah, so SAS files, I believe, can be read directly with Python. What's the extension on the Access database? Do you have the actual file? Is it a MDB file, or sometimes they're called ACCDB for Access database?
I'm not actually less concerned with Access. It seems like I can save it as a CSV file.
Oh, okay.
The SAS is I don't know if it can be processed with pandas or other packages.
Yeah. So there's a function called read SAS that just reads in an SAS file into a data frame. So, and there are similar functions for reading SQL databases. So if you can export the Access database into a SQL database, you can read that as a data frame. Stata files. Let's see. There's lots of different formats that are Excel files, JSON files. Sometimes databases are in, or data sets are in JSON format. There are a whole bunch of them just directly built into pandas. And then let me, I can pull up the full list here. So those are the like natively supported file formats. But then if you encounter another format that's, from a popular package, and most public data sets are formatted for, some commonly readable format, then there's almost always a converter that we can use to like convert or get Panda support for that file type. In the extreme case, you can write your own parser, but that's like usually annoying. So we hopefully won't have to do that. But technically Pandas supports every data type because you can write a customized parser if you wanted. Happy to like dig into any of those data sets has anyone started playing around with data, or do you want to do that on your own? Because this class time is a time for, if you like, I'm available now to like dig into your data with you. So if you want to try to make some kind of plot that you're excited about, like we can try to put that plot together now. We can even track down data sets.
I posted my data set, a small data set on our like collab, and that is idea to make a pie chart. I haven't started making the pie chart, but just wonder.
Okay. Well, do you want to post a link to your data set, and then I'm happy to, we can make a pie chart if you want. And then while you're tracking that down, Emily, did you have a question too?
Yeah, I was wondering about the data set that you shared last week, or not last week, like yesterday. And then Alex was saying that there was like a too long to load thing that I'm also having come up, and I'm not sure how to find it otherwise. It's like, I know you said going to GitHub or something in Colab. I'm having trouble like figuring out how to get to it.
Yeah, why don't I share my screen and show you how to do that?
Okay.
Okay, and then we can play around with the data set that Marie just shared. Okay, so the first thing you do is you go to colab.research.google.com. That's the Colab website. And then this, dialog box, can you all see that? Okay, that comes up. So you want to click the GitHub tab because we're interested in opening something that's hosted on GitHub. And usually you want to check the include private repos flag if it's not already checked. And then we'll go to the repository drop-down menu, and you want to select Context Lab Storytelling with Data. So
a question I have, I guess, like for me, when I am here, I guess it's like typed in my username instead of your username. Should I change it to say Jeremy Manning then as the username in the search?
is that repository not showing up for you?
No, it's typed in with my username instead.
And you have a different list. So one thing you could do is if you go to the course GitHub page, you could fork the class repository, and that will put it under your username.
Is it, so it's like storytelling with data though? Is that the one you went to? Sorry.
Yes, that's the one.
Okay,
Yep.
so if I searched your name, then I see it. I just had the wrong username, I guess.
Okay, yeah, that's interesting. Okay, and then you want to go down to where this particular notebook lives, which is in the data stories /VTDOH.
Okay.
So we'll have to look at that, and then if you scroll down a little bit, it's right here.
Okay, thank you. I see it now.
And then if you just click on it, it should open the notebook.
Yeah, thank you.
I can also post the link. So the like open in Colab, like what that link is actually pointing to is just like, so the Colab website, and then /GitHub means it's on GitHub. And then Context Lab is the organization name. Storytelling with Data is our repository. And then Blob is where GitHub stores all of its data. It's, I don't know, a nerdy computer thing. And then Master is the branch. Data Stories is the folder. VTDOH is the subfolder. So everything past here is like within this GitHub repository, what's the path? And so you can do this for any notebook in the class, and it will, so you could change the story folder and the notebook name, and then it'll open in Collaboratory. And then to actually run it, you want to press connect, and that will copy it to Google Cloud, and then runtime, run all. And I will certify that the notebook is safe and won't mess up your computer because I'm nice. Okay. And yeah, so then it'll, run through all the stuff. And what this particular notebook does is it makes some animation, like animated maps that, are based on some of the data sets that the Department of Health shared with us. So once all the stuff installs, we'll get to see some plots pop up. Looks like it's still chunking along there. Okay. Well, that'll go for a bit. Okay,
Oh,
but in the, I'm sorry, what?
If you had something else in the meantime, I was going to say in the meantime, I think I made a pull request properly to add a little bit more data. Dang
Nope.
it.
Okay, but let's explore that. So what is your GitHub username?
Alex Wells -22.
Just like that?
Yep.
Okay. Okay.
Ah.
So did you notice something or?
Well, just, yeah, mine also says that this branch is one commit ahead of the master.
Okay,
conflict.
yeah, great. So that means you're up to date and you've done something extra. Okay, so to make a pull request, we go to the pull request tab, and then basically you always click the green buttons. So the first green button is new pull request, and then we have to figure out what you actually did. So looks like you added some data sets and you added them to reasonable places. That's all great. So now you can create a pull request.
Okay.
And then the next green button, create pull request. And that creates a request that gets sent to me. So you don't typically get to see this page,
Okay.
but this is what comes on my screen when you press
Cool.
that button. So I was just pretending to be you there. Now I'm back to pretending to be me, or I guess I'm actually me.
You are, okay.
I am me, as far as I know. And then I click my green button. So if you like overwrite a file that someone else also overwrote, and or like you forgot to pull down the latest changes or sync your repository with the class repository, then I wouldn't have this option.
Okay.
The other thing that I always do is like check, okay, did you like put your files in reasonable places? So if you submit the pull request and I hadn't just gone through your files, then I'd have to first check to make sure you did that right. But I checked it when I made the pull request. And so now I can merge the pull request and press the next green button. It's always about green buttons. And now your data set is part of the class data set. But interestingly, now your fork is behind, is not up to date anymore. So we can go back
Oh.
to Alex Wells 22. So your fork of this repository, and now you're one commit behind. So
so I can go back in and refresh that and bring it up, or you can.
So
yeah, I can do the fetch upstream on my end.
Oh, you can? Okay,
Yeah.
great. Okay.
Cool.
And that will bring you up to date.
Awesome.
Cool.
Oh, thank you. Well, now
sure.
I know why that hadn't been confirmed.
Cool. Okay, did everyone, and I guess the other piece to make sure everyone's on the same page with is if you want to upload your own data, you'll have to go to your private fork. So, because no one has write access to the class repository, so you can't like mess up everyone else's copy of the class. But if I want to upload data for me, I'll go to my username and then /storytelling with data. If that doesn't work, you'll have to fork the repository to make sure that you have a copy. And then let's say you want to upload some Department of Health data, you'd go to the data stories folder, scroll down to VTDOH, which is the name of this. Oh, I see, I haven't synced my repository. So I'm going to fetch upstream to bring myself up to date. Okay. Data stories, and then VTDOH. Okay, now all of Alex's data is there. But if I wanted to add a new file, you go to add file, and then you can either upload a file where you can like drag and drop something from your computer, or you can create a new file right within the web page, and then like paste in a CSV file or something. And then you just want to name it whatever your file name is. Okay. And then remember to do a pull request, you go to the pull requests tab, new pull request. Of course, I haven't changed anything, so I don't have any more green buttons. Once you run out of green buttons, something has gone wrong. So there's nothing more I can do here. So I'm done. I can't make a pull request because I haven't changed anything. Okay, so let's go back to, okay, so it looks like all the stuff is installed. We've loaded in some data. And the data sets that were shared with us are of this format. So they've got, well, a bunch of columns that, like, some of which are kind of self-explanatory and others of which I don't know what they mean. So like reporting group code, I don't know what that is. Topic, it seems somewhat redundant. So for some reason, I've noticed all the values of each spreadsheet that you download are the same under this column. So it's kind of a wasted column, I guess. Indicator is like different things that are measured. And then the indicator value is like the value of the thing that's being measured. So if you wanted to know like percent of adults age 18 to 64 with health insurance in the year 2008 in Addison County, Vermont, then, well, that data is missing. But if it wasn't, it would be in this entry here. Some data is not missing, and so you actually get a number. And then there's this pre-computed statistical summary that compares the values of the given indicator to the like average of like the statewide average. So if it's like statistically indistinguishable, it says same, which if you've taken stats here, you know that like absence of evidence is not evidence of absence. So it's not totally right, but we can give the Department of Health a pass. Maybe they haven't taken Psych 10. And then sometimes it'll say higher, sometimes it'll say lower, and they're doing some kind of statistical test there. Yes, Allison.
Okay.
You are muted.
I have a few questions. So my first question was, or is, how many like graphics do we need to have for the video? And like, what's the breakdown of the video supposed to be in terms of these graphs versus storytelling? I know you're laughing, but it's a serious question.
No. I wasn't laughing at you. I just spilled coffee all over myself. So that's why I'm laughing. I'm very clumsy.
Are you
I'm
okay?
laughing at myself. I am okay. But
are you burned?
no, I'm not burned. Gonna clean off my keyboard, which hopefully is not fried. Sorry. Unfortunately, as I was spilling the coffee, I was not listening to you.
Okay.
So you'll have to repeat what you said. Sorry about that.
You want to get some paper towels or anything?
I'm good. I'm paper toweled up. Got my I don't know if you can see, my wife is right across the office from me. So sometimes, usually we're not lecturing at the same time, but occasionally you get voice feedback there.
Is she also a professor?
She's not, but she does sometimes teach in, she does marketing and graphic design.
Oh, cool.
So courses related to that, she sometimes guest lectures.
Oh, cool. Okay.
Sorry, but what were you?
Yeah.
What were
So
you asking? Yeah.
my question was, I have a few. The first was, actually, now I forget the first question, so I'll just ask something else. My first question was, how many data? Thank you, Emily. How many data visualizations do we need to have in the video? And like, just to break, are there any samples that we can view? I don't know if that's like from previous years, just to get a sense of the breakdown with these visualizations or just the storytelling.
Yeah, so first of all, there are samples from previous years. So if you go to the like course outline, I can post a link here.
Okay.
If you click on module 4, then you'll see like submissions. Oh, sorry. Oh yeah, submissions for like last year, for example. And this will pull up a YouTube playlist of all of last year's submissions.
Oh, there were only 2. Okay.
So last year, the whole class did 2 submissions. Looks like let's see, did I post? Yeah, I could pull up some examples from previous years too, but
yeah, that would be great.
I guess I haven't added them in yet, but I'll do that today.
I guess, and also telling us which ones are good ones to look at as models would be helpful too.
Yeah, so I think in general, I mean, so it's a different topic this year, so it's not going to be exactly the same. But in general, to answer your first question, like how many graphics are needed, how many analyses are needed, I guess 1 or more. So you can tell a whole story with just 1 graph, if it's the right graph or the right visualization. If you want to like dig into some data set and like really, kind of ask a multi-level question, then you might need multiple graphs to dig into different parts of the data set. But, the kind of formal requirement, I guess, of the assignment is 1 or more analyses or visualizations. But that's I guess between 1 and infinity is a pretty wide range.
Okay. And then I guess going back to, can you go back to like when you were looking at the data, like for instance, like arthritis?
Oh, yes.
Okay, so a couple questions for that one. So I guess in terms of geography name, like I think we only are concerned about Windsor, right?
Well, it's up to you what you want to do. So one of the things that I did in this sample file is I thought you might want to create maps or like compare different counties to each other geographically and that sort of thing. So it's somewhat annoying to do that. And so I wrote some code to enable you to do that. And so the kind of two things you need are a GeoJSON file, which I think we played around with maybe last class or something like that, which kind of outlines in latitude, longitude coordinates as if those are XY coordinates on a like 2D plane. What's the polygon outline of each county? So it like defines the shape of each county on planet Earth in latitude, longitude coordinates. And then each county gets a unique identifier. And the one unique identifier is called a FIPS code. And there's this other spreadsheet that lists all the FIPS codes for all counties in the United States. And if you put them together, so here's what they look like. So you've got like a FIPS code, which is just like some number, a name of the county, and then a state. So there's some overlap between county names across states. And so you have to know both the name of the county and the state. And then this code here adds a FIPS code to, like, given the county name, to each row of the table. And then as you scroll down, you can like start to create actual maps that there's the demo code here will like color different counties according to, I think this is based on insurance, percentage of Vermonters with health insurance in that county. And then I've made it into an animation so that you can like view it over the 4 years that are included in the data set. So here's what it looks like in 2010. And then over time, you can see that like more people are getting insured.
Oh, that's cool. And so we could just use the same code for that.
Exactly. Yeah. So the idea of, I don't know, I guess it could be interesting that more people are getting insured. So that seems like progress. But then even if you didn't think this particular question was interesting or this particular visualization was interesting, you can see that like if you organize data in this way, your data set in this way, you can like swap out the insurance data frame for your data frame and use the same code and get out a figure like this. Another somewhat interesting thing you can do is like you can break down different measures into what are called facets, which are like sub-panels of the same figure. So just as a second example, here I'm showing like adults and then kids that are like in their percent insured. And then that's also done as an animation. So you can see those two things changing over time. Again, may or may not be interesting to like look at this particular thing, but now you have like sample code for making these sorts of plots for this data set.
Gotcha. So I guess the reason I was asking about the counties you cared about was, or I guess more relevant, is how do you filter by, say we just want to filter by Windsor County or only include that data? How would we do that?
Yeah, so in general, let me go up to, okay, but I'll just pull up the arthritis data set. So, or sorry, access data set, that's the first one. So if you want all the rows where a particular column has a particular value, then there's a pandas function called query, which if you're familiar with working with databases, it's like kind of like a database query. It's not SQL code. So has anyone worked with databases? Like, select from where? No. Okay, then I won't use database terminology. Okay. So we want a query, and then your query is entered as a string. So the county names are given by the geography name column. So you have to paste that in. And then you want the geography name to equal Windsor in quotes. And that will return, oh, oh, maybe I need quotes here. Okay. Did I spell it wrong or something? Geography name. Okay. Maybe it's, let me just make sure it's not a space thing. Oh, it's just, I typed the wrong type of parenthesis. That's silly. Windsor. Oh, silly pandas. Okay. No, that's not going to work. Column with space. Okay, how do we do this? You can, okay. So you enclose it in backticks. So a backtick, if you have a US keyboard layout, it is above the tab. Well, I guess depending on your keyboard. Let's see if this works. There we go. Okay, I would not have known that otherwise. Okay, so there's single quotes. That's like a normal Python string. Double quotes is an alternative to a Python string. But if you want to include another string inside of a string, you need to enclose it in like a different kind of quotes. So if I have a single quote string and I want to represent another string inside that string, I have to enclose it in double quotes. Or if I had a double quote string and I wanted to represent a different string inside it, I'd need to enclose it in single quotes. Does that make sense? Okay. And now we've got geography name, which is a column name. And so like if I had used double quotes for this, what it's doing is it's saying for each row of the table, test whether this statement is true. But the thing is, the string geography name is never equal to the string Windsor. So this will just either crash or, yeah, okay. So it just never works out that way. And so to specifically refer to a column name, each column is assigned to a variable with the same name as the column. But then there's this extra thing where if you've got a space in your column name, pandas won't know how to deal with it. And so apparently you have to enclose columns with spaces in these backticks, which is like the tilted single quotes. Okay, so now we've got all of the Windsor County data. We could also, so that's a data frame. We could also filter it by year. Oops. So we could say, and years, so that's the column name, equals 2010. Oops. Oh dear. Okay. Oops. Apparently there is nothing there. Oh, okay. There we go. So it's actually an integer is what the years are. Integers don't have, they don't have to be treated as strings. Does that make sense?
Yeah, that's helpful. Okay, so now that you filtered it, well, okay, I guess, are these like tables supposed to be cut off, or is there like a way to see the entire table? Because it looks like I didn't even know Windsor was in the table until you just searched for it, because all we can see is that Addison is in the table.
Yeah, that's a great question. So one way to get it to like get all the values of a particular column is, let's say I want all the counties in this column. So access of geography name will give me a pandas series with that column. But I can do NumPy unique of this whole series, and that'll give me the unique values of that series. So we've got Addison, Barry, Bennington, et cetera, all the way up to, well, Vermont isn't a county of itself, but this is like statewide data. So if you filter, yeah, so that was something that confused me when I was looking at this data earlier. So axis dot query geography name equals Vermont. The geography type goes to state instead of county, and then all the like comparing to states values become nans, because you can't like there's no statistical way to compare something to itself. I guess everything is already itself. Anyway, so that's something that you could filter out. Like if you might want to get all the rows where geography type is not state, for example. So we could say, I don't know if this will work. There we go. So this exclamation point equals is not equals. In some languages, it's tilde equals is not equals, but seems like Python likes the exclamation points.
So yeah, that's very helpful. I guess I'm kind of trying to like, I'm not doing this one, but I'm kind of trying to think of like if I was going through it and how I would, the questions I'd want to know. So I'm probably just going to keep asking questions unless other people have questions. That's okay on how you'd actually go.
That's fine with me. Yeah. Do other people have questions you want to jump in with, or should we keep going with this?
Oh, sorry. I just wonder if you can show just how to do a pie chart, because I looked online. They have like the manually, you kind of put the percentage or the number there, but I think there might be an easier way to just to drag the data from the data set.
Yeah. Okay. So you posted in. Okay. So you've got your. Sure. So maybe we'll look at this, and then Allison, we can get back to digging into your questions. Is that good? Okay. So collab, we'll open up a new notebook. Pie chart. Let me share this with everyone. Okay. There you go. And I'll put it in Slack too, so that, oh, we have a record of it. Please, pie chart notebook. Okay. Okay, And then let's import Plotly Express. So, and also pandas. So import pandas as PD, import or from Plotly, import Express as PX for Plotly Express. Let's get NumPy too in case we need that. Okay, and now I have to look up how to make a pie chart. Oh, it's just the pie function. That seems reasonable. Values. Great. Okay. So the two things we care about are values and names. Okay. Oops. Okay. So eventually we'll make a pie chart with our data frame, and then values equals something and names equals something. Okay, but let's load in your data set to deal with that. So I see it's a CSV file. So we'll make our data frame pandas read CSV of this whole thing. Okay, so it loaded in okay. And then let's check it out. What is here? Okay, so we've got question, answer, N, and percentage. Okay, great. So it looks like this is formatted in a somewhat inconvenient way for like, you know, answering a question. But if we wanted to look at, so let's see, question, like what we want to do here is, so we've got the question, and then this same value is, I think, interpreted, it's going to be, it should be interpreted as like anything after it until you have some non-nan value should have the same question. I don't know if you can forward fill. Yeah, so we could see like, we've got some nans. So I don't know if you can forward fill strings, but let's see. Okay. Oh, here we go. That looks useful. Fill a string value forward. Let's see. Oops. Okay, so we've got this. That's a series object. If we wanted to make it a data frame, it would look like this. If we forward fill it, that'll copy the same question, the same, like the question name to all the nans that are after that question. And then we should replace the question values with this, with the forward filled values. Okay. So now let's see what this looks like. Oops. Okay, so now we've got our like filled in values. Okay, and now we've got different questions and different answers. So let's have our values be n, which is like the counts, and then the names are going to be probably the answer that people gave. And then we might want to make a different pie chart for each of these questions. And let's see if there's a facet column. Pie charts, what are the options here? Well, let's see. I think I did this in this notebook, and what was it called? Facet call. I don't know if this will work for pie charts, but we want the question to determine. Okay, that doesn't work. So I was going to try to make a different panel for each question. That doesn't work. So we can look at, here are all the questions. The unique questions are this. So let's make a whole bunch of data frames. So we could say df.query of question equals Q. For Q in all the unique questions. And there we go. Okay, so this will create oh, sorry. Let me see. What did I do here? Okay, that gives me the questions. We'll query question equals Q. Let's see if this works. No. Because I didn't spell query right. And what else am I missing? Another parentheses. Okay. Doesn't like that. Let's see if this works. There we go. But they're all empty. Okay, we'll do this the old-fashioned way. Data by question, we'll make it an empty list for Q in np.unique. For each unique question, let's print Q. Okay, so that worked. And then we'll say, what if we want to filter just the rows with that question? So we could say df.query question equals, and then this whole mess here. Okay, so that seems good. Okay. We can just append question equals. Oh, I probably just forgot to fill in a format string. Okay. Yeah, so I'm pretty sure this could just be this. Okay. There we go. Okay. Sorry about that. Okay, so data by question of 0 is all the, it's like all the data from the first question, for example. and data by 0 for the second is all the data for the second question. Okay, that was somewhat messy. Now let's do an example pie chart, and we'll just plot a pie chart for the first question, which isn't showing up. Why is that? Oh, N has a little space after it. Weird. Okay. So here is a pie chart for the first question. And then we could say maybe title equals like data by question of 0, and then the first row, and then the question. But you have to spell it right. There we go. So now the title of the plot is this whole thing. Okay, so I'm going to save that. And then you can do this for each, we could do this for each question if we wanted. So say figs equals this, question of I. For I in range length data by question. What have I done here? Okay, that's reasonable. Oh, this doesn't look right. There we go. Okay, so now we have a bunch of figures, and then now we have like figs of 0 would be the first pie chart. Figs of 1 would be the second pie chart. This would be the third pie chart. And the fourth pie chart. And I don't think there's a fifth one. Oh. Okay, cool. That's pie charts. There we go. So I'll compute the percentages and everything. Cool. Okay, let's get back to, okay, so Allison, did you have, or Funnery, does that sufficiently dig into your question? Okay, great. Yes, Allison, what were your other questions?
Okay, so I guess my next question would be like, all right, so like you've separated out the data by like regions we care about, and by the, I guess, relevant years. Like, how do you, I mean, I guess you can make graphs and just see if anything looks interesting, but before, like, what can we do, like, to figure out, oh, we should make a graph of this, or like, how do we make meaning out of these tables?
Yeah, so I mean, that's the question. Like, that's so that's what we have to think about. So I guess the first thing to do with is like frame the problem. So what question are you trying to answer with the data set? So like, let's say you wanted to look at like is like incidence of arthritis correlated or related to incidence of like heart issues. So then you might want to say like, okay, across time or over different across counties, like are the values. So if you wanted to look across time, you could say averaging over all counties, or you could even look within a county. But you do one spatial filter step, either you average across counties or you just filter to one county. Over time, over the years within that county, what are your arthritis measurements and what are your heart measurements that you care about? And then you could correlate them. Or if you wanted to, how would we do that?
Or I guess maybe, I don't know, first, like it's helpful to think of like different kind of questions you could go about. And then when you could talk about how you go about doing the coding part.
Sure.
Whatever you recommend.
So we could, yeah, I mean, one thing we could do is just like look at the question I asked, like, is arthritis correlated with heart, or are arthritis issues correlated with heart issues? Okay, so we've got two data frames that are going to speak to this. We could look at the arthritis data frame and the heart data frame. So the first thing we want to know is like, what is even in these data frames? So if we look at arthritis, you know, we might want to visualize it. Okay, and we've got different indicators. So what are those indicators? Well, let's look at the unique indicators. You do have to spell things right. Okay. Oh, it just looks like there's one indicator for this particular data set. % of adults with diagnosed arthritis who have activity limitations. Okay, so that's what's in that table. And then let's look at the heart stuff. Okay, we've got different heart measures. Heart disease death rate per 100,000. Adults, or proportion or % of adults with a cholesterol check in the past 5 years. Adults with hypertension. Children and adolescents with hypertension. Stroke death rate per 100,000. Let's see. So what if we wanted to correlate percentage of adults with diagnosed arthritis with percentage of adults with a cholesterol check in the last 5 years? Why not? So first you have to think about like, what should this data frame look like? Like, what are the columns going to be? Well, maybe we want one, you know, the index of the data frame might be county. So each row might be a county. And then the columns could be like, we could have one column for arthritis measurements and another column for heart measurements. We might want to have a third column for year in case we want to separate things out by year. So let's make that data frame. So to create a new data frame, let's see, the index is going to be the unique geography names. So let's just make sure it works. Okay, those are counties, and we could filter out Vermont. Because we don't want to look at statewide. Okay, so here are all the Vermont counties. And let's make that our index. And then we'll have some columns. So let's see, an arthritis column and a recent cholesterol check column, and then maybe a year column. Maybe that'll be the And let's check out what this looks like. Okay, so right now there's nothing in that data frame. But we know how to fill it in, right? Because we could say for each year, actually, this is making me realize we probably want year and county to be the index, right? Or maybe we could have a separate table for each unique year. So maybe we don't want year in here. Okay. Okay, so let's figure out what years are we working with here. So we've got, looks like the years column. And we've got heart years. But some of those are ints and some are strings. Okay. So I actually wrote a code, some code to deal with this. Where is it? So, oh yes. So we want to convert strings to years. Okay, so we'll have to. So, okay, so that'll convert everything to years. Okay. And then what are the unique years? Okay, we've got these years for the heart data. And these years for the arthritis data. They're not the same. But there's some commonality. So heart years are these. Arthritis years are these. And then maybe we want to make, let's see, so we could make these sets. Or no, sorry. Okay, we've got our years. These here. And then maybe we want to know like what years are in common between these. So we could say set intersection between set of heart years and set of arthritis years. Okay, so here's the unique common values, and then we can make this a list. Common years, and then we'll sort it. Okay, so here are the years we're gonna deal with. Okay. Okay. So I don't know. We could just do a sample and filter out just 2016 data. So to filter out 2016 data, we could say well, let's see. First, the heart data has year listed in this inconvenient format, but we could make a new format or a new column just called year that has the like cleaned up values. Okay. And then we could do the same thing for the arthritis data. Okay. So now we've got the heart data has this extra column year, which has an integer format. We could filter out the 2016 data. Oops. What did I do? By using query. Year equals 2016. And then we could do the same thing for the arthritis data. Okay. And now we've got part 2016 is just the 2016 data for, I don't know, heart. Okay, and we were going to focus in on a particular question, which was percentage of adults with a cholesterol check in the past 5 years. So where was the actual value there? Okay. Okay. So we want to filter out everything where the indicator is that. So indicator equals this whole thing. Okay. Now heart 2016 is all of this data. And then we just want the indicator values. So that'll be what we fill in for our measures. Okay, so this is like filtered heart data. And then arthritis 2016 is going to be like cleaned up arthritis data. Okay, we just want the indicator values, and that's what we'll put in this big data frame. So we could say, if these are all our counties, I apologize, I'm going over. If some of you need to leave, that's fine. I can finish typing out this example for those who can stay. Okay, bye, Akia. So for each county, then we could filter the data frame just to that county. Okay, so let's say we want, so DF of that county of, recent cholesterol check is going to be heart 2016 of indicator value. And then the data frame in the arthritis column there is going to be arthritis 2016 of indicator value. And okay. What is going on here? There we go. Okay. Sorry. There we go. We don't want Vermont. If C not equal Vermont. Okay. What did I do wrong here? Okay. Okay, got a typo. Oh. Wow, okay, that's good. Okay, now we have our data frame with all the filled in values, but that does not look right. So we want, let's see, geography name equals that county. All right. Okay. Let's see if this works. No. We want it to be just those values. Okay. Now we finally have an organized data set. And then let's see if we could do the correlations between these things. Oops. What are our columns again? Okay, so we want to correlate arthritis with recent cholesterol check. Okay, those are values. Let's see if this works. No. Okay, so we need, oh, X. Sorry. This is it. What? That should be an array. Seems right. Ooh, maybe they're not all floats. Ah, goodness. Okay. Well, I guess the correlation between those is 1. That seems silly and probably not correct. Yeah, it's definitely not right because that can't be right. Okay, we've got our data frame. We've got arthritis. Let's see if pandas has a correlation. There we go. That looks useful. But it doesn't actually return anything. Yes, Allison, are you raising your hand again or?
Yeah, my question was, so well, I guess 2 things. One, thanks for trying to figure out the correlation. And if you can't figure it out now, if you could just post it in Slack, that would be awesome.
Yeah, sure.
So it is literally just me. Okay. And Emily happens to be there, but